Okay, hello there. Let me see if I can make this a little bit. It's a little brighter, isn't it? Okay. So this is problem number 3 for the Unit 5 test. And let's go ahead and click off of that so we can see this. It says, you will need to print this off in order to accurately complete this assignment. Please show all your work. Please show all of your work. You may only use a pencil, straight edge, and a compass for your construction. You are the owner of 3 pizzerias in the town of Squaresville. Here's Squaresville. To ensure minimal delivery times, you devise a system in which customers call a central phone number and get transferred to the pizzeria that is closest to them. Your job is to determine where the central office should be located. Okay, so we want an office that's equal distance from A, B, and C. And if you didn't know by now, you could totally find that by using the perpendicular bisector. So what I'm going to do here is I am going to create a triangle with these 3 points, given points here, A to C, B to C, and then A to B. Okay. All right. So let's just go ahead and scroll down just a little bit. Question number 1 says, how many perpendicular bisectors do you need to construct? Now, we could construct all 3 perpendicular bisectors of the triangles. One for this side, one for this side, and one for this side. But I really only need 2. Okay, we know that all 3 perpendicular bisectors are concurrent, but really we only need 2 to help us find our point of concurrency. So I'm just going to write, we really only need 2 perpendicular bisectors, but 3 would work as well. Okay. Okay. So let's go ahead and construct our perpendicular bisector, if you guys don't care. And notice it also says label the central office point D when you, right here, label the central office point D when you find it. Okay, so let's go ahead and find this place. Okay, so remember to construct a perpendicular bisector, we're going to use 2 endpoints of our line segment. Okay, and we'll just go ahead and go a little more than halfway, and you can just eyeball that there if you want to. And this is where it gets a little tricky, and I'm sorry you can't see because of my big fat hand is in the way. But, and of course it moves. Of course. Lovely. Okay. Oh, now you can see it. Let's try it this way now. See, notice I didn't change the distance of the compass, and you can see right here we create 2 points where the arcs of the intersect meet. Arcs of the intersect of the arcs meet. There we go. And then of course I create a line segment connecting the 2 intersecting points. And what's cool about that is this is a 90-degree angle, and we also know that this is bisected here and here. Now I only need to do that on one other side. I can choose AB, I can choose BC, it doesn't really matter. And I'll choose, I guess, BC. It needs to just be a little more than halfway. And just to make sure, I'll make it closer to B. And, oh dear. It just is not as easy as you would think it would be. There's our first arc. Not changing the distance of the compass. Come over to B and there. Okay. And we can see the 2 points where the 2 arcs intersect. Let's go ahead and just draw a line here. Perfect. Awesome. So we can see, and by the way, again, just to remind you, this is a 90-degree angle and it bisected the line segment there. A little messy, but we can see right here is our point of concurrency. Okay, oh, you can't really tell, but that is supposed to be red. I can see it's red here. Okay, so what we can see is and we know, by the way, label that point D. So this is point D. Okay. So let's look at this. What is the name of the point where the 3 perpendicular bisectors meet? Well, we could say, well, D, or really what they're looking for here is, it is called the circumcenter. Okay, if you guys remember talking about this in class. And what is special about this point? Well, what is cool about this point is this is equal distance to all 3 vertices. Okay, so if I were to draw a line from the circumcenter to each vertice, and like it is so close to being a right triangle because it is almost on the hypotenuse here, but all 3 of these line segments would be congruent. And that's what's cool about these perpendicular bisectors. I don't know if you can see those very well. Maybe I'll highlight them so you can see them a little bit better. This guy, and this guy, all of those are congruent. So we know that D is right in the middle of all 3 of these pizzerias, all equal distance. This guy. Okay? So what is special about that point? Well, we just talked about that. It is equal distance, or you could put equidistant distance from all 3 pizzerias. Okay, that's what looks supposed to be an A, right? Or is it supposed to be an E? No, it's supposed to be an E. That's right. Okay. Pizzerias. Okay. If a house located on the corner of D and 4th Street, so D and 4th Street right here, which pizzeria would take the order? Of course, C would take the order. Okay. That's all. I hope this helped. That was a really fun problem. I like that one. And I hope it makes a little more sense now to you.